So we skipped section 5, 10.5, and this is actually, believe it or not, ta-da, the very last section that we're going to do in the book. And this gives us applications of the exponential function. So buckle your seatbelts, this is it. This finishes the book. Not often that happens. So, the compound interest formula, which is what we're going to be looking at here, tells us that A, the final amount, is equal to P, your initial investment, times 1 plus R, the interest rate, over N, the number of interest periods per year, raised to the N times T. So that's what tells us how much money we make. So let's just look at an example so you see how things get plugged in here. Okay, so here's a straightaway problem. We know what our initial investment is. We know what the interest rate is. We know how many times per year it's being compounded. Monthly means 12 times a year. And we know how many years. So therefore, take out your Inspire, and the final amount is going to be 25,000 times 1 plus, now it's not 3. 3% means 0.03, and that's a place that is very easy to make a mistake. Divided by N, number of interest periods per year, raised to the N times T, number of years. So this is one where you need your trusty Inspire, and what do you get? So if you press the keys on your Inspire correctly, that's what you should come up with. $39,185.80. Okay? So that's simply straight away just plugging right in to this formula. Okay, so this is a more interesting problem. We want to know how long do we have to wait for $15,000 invested daily at 4% to grow to $70,000. So really what we're looking for is how many years, and that's our variable t. So the equation that we're trying to solve is 70,000 is equal to 15,000 times 1 plus 0.04 over 365 raised to the 365 times t. Now, we don't really have any way to solve that by hand. However, you do have an Inspire. And the way you solve this on Inspire is simply to execute the following command. Solve that whole equation for t. So, set it up, press pause, solve the equation, and let's see if we agree. I'll be right back. So, if you execute this command correctly, you should get that t is equal to 38.51 years. So you got to wait a long time for that $15,000 to grow to $70,000. So, believe it or not, that concludes the work that we have in the textbook. There are some additional topics that we'll be looking at after this, dealing with sequences and series, probability, and statistics. But that finishes the work that we're going to get out of the textbook. All right, have fun with these problems, and see you next time. Bye-bye.